Awesome. Okay, so for today's lecture, we're talking about loops and debugging. I opened the pre-reading yesterday, so hopefully all of you had a chance to at least glance over some of the slides. But today we're going to start with something that's pretty simple, but also one of the more core concepts of programming, which is the idea of loops. What are computers good at? Computers are really, computers are really good at not necessarily being creative and doing kind of live thinking, but what they excel at is actually doing the same task over and over and over and over again. All computer programming essentially boils down to a binary, which is I either do something or I don't. And when faced with that kind of logical choice, a computer can make those decisions not only very quickly, but at a scale that most humans can't comprehend. And so when we start off with looping, that's because that's one of the main reasons why programming even exists. Is because we need to do something at a scale, at a pace that humans can't really sustain or with the same level of accuracy. So the first loop we're going to start off with is something called the while loop. And you'll notice that we're going to talk about two types of loops and then some other conditionals. But with the looping part of it, just know that the loops may look very similar, but just be careful in terms of how they're used and what assumptions we're making under each scenario. So for a while loop has three key elements. The first is the while keyword. The second is a conditional expression that evaluates to a Boolean. And the third is a block of code. So breaking down all three really quickly with the example here, the while keyword. So in most text editors, if you're running JavaScript, if you type in the word while, usually that code will change to a different color. So it may turn to red if your normal text is white or yellow or something else. And the reason for that is because while is what's known as a reserved word in JavaScript. Reserved as in while comes predefined within the fundamentals of JavaScript. It's the same with the word function, same with the word let, same as with the word while or for. What that means is you can't make a variable called while. You can't make a variable called for. You can't make a variable called function because those words inherently already have meaning in JavaScript. And so when we say that your loop requires, or rather a while loop requires a while keyword, it just means that while comes predefined into all JavaScript out of box. So we're going to talk about how you use it, but you don't have to worry about creating the foundation of the while keyword. The second part is a conditional expression. And so if you look there on line 6, you'll notice we have our while keyword as the first thing. And then afterwards, we have something in parentheses. And what we have there is what we call conditional. That's actually a conditional expression. So if we take a step back and think about what a while loop really is trying to do, a while loop is actually asking you, hey, do you want to do this, or do you want me to do this? And the answer is always going to be one of two values. It's either going to be yes, do it, or no, don't do it. And those are the only two possibilities, at least when we're using a while loop. And so that's why on the second bullet there on line 3, we say it's a conditional expression that evaluates to a Boolean. The reason why it evaluates to a Boolean is because a Boolean is a data type with only two possible values, true or false. And they line up very nicely with the use of a while loop, which is, do I want to do this? Yes or no, true or false. And so whatever we put into those parentheses there on line 6 in the conditional, no matter what we put in there, JavaScript will do its best to eventually make it into a Boolean. We'll talk about coercion in either later here and touch on it again in a later section. But just know that when you have a while loop, the thing in your parentheses will always eventually be coerced, or it will be changed or forced into either a true or a false, because a while loop has to know if it needs to keep going or do the thing that's in the loop. And then the third part of the while loop is what we call a block of code. That's basically everything between the open curly brace that ends line 6 and the closing curly brace that starts line 8. So everything in between those curly braces are the block of code. That's the block of code that actually gets run if the conditional on line 6 returns true. If the conditional returns false, then we basically stop running and say, hey, we're done. We don't check again, we don't move on to anything else. And after we get to an instance in which the conditional is false, we move on to line 9. Okay? So once again, how the while loop is used is when we let's say we're a computer and we're going through this line of code. When we hit line 6 and we see there's a while loop there, the first thing we do is we check to say, hey, is the conditional true or false? If the conditional is false, then we skip the block of code on line 6 through 8 and we move on to line 9. If the conditional is true, however, then we do the block of code between lines 6 through 8. After we complete lines 6 through 8, we then go back to line 6 and we check our conditional again. We say, hey, are you still true, right? Or does this still return true? If the answer is yes, it returns true still, then we do lines 6 through 8 again. After we finish line 8, we then go back to line 6 to our conditional and we check again to see if the conditional is true, and if it is, we do the block of code one more time. And so we basically keep doing this block of code over and over and over again as long as the conditional is true. We only stop this while loop when the conditional statement becomes false. And we'll talk about kind of why that's both a good and a bad thing in the future slide. But does everyone kind of conceptually understand what a while loop does? Cool. So it's probably easier to explain when we're looking at a real example. Here on line 1, we create a variable called count equals 3. By the way, can you guys see the upper right-hand corner of my screen where the printout is? Okay, great. You can, but I can't, so let me change it. It's because of the way Zoom puts people, there we go. Okay, great. So on line 1, we create a variable called count, and we set it equal to 3. On line 3, we hit our while loop. And the first thing we do in our while loop is we check to see what's in between the parentheses there on line 3. If what's between there returns true, then we do the code block. If it's not true, then we skip the rest of the code block. In this case, we move on to line 7. So on line 3, the first time we hit the while loop, we say, oh, in the conditional, we have this expression that's count is greater than or equal to 1. Well, count, as we define it on line 1, is equal to 3, and 3 is greater than or equal to 1, and so therefore we can say that the while conditional returns true in this instance. Because it returns true, we move on to the code block, which is on line 4, and line 4 asks us to console log the phrase count is, and then the number count. And so that's why on line 4 there, or on top right-hand corner of my screen, you see us print out count is, and then the number 3. After line 4 runs, we then run line 5, and in case you're unfamiliar with it, the minus just basically means subtract 1 from count. So when we do that, we're basically making the implicit assumption that count is going to be a number. After we decrease count by 1, we've finished our code block for this iteration of the while loop, but we're not done, because now we have to go back to line 3 and check our conditional again. Except this time when we check whether or not count is greater than or equal to 1, count is no longer 3, it's now 2, because on line 5 we actually changed count. We decrease it by 1, so now count is 2. However, 2 is still bigger than or equal to 1, and so therefore the conditional on line 3 is returning true still. And so because it returns true, we then go into our code block on line 4, and now we're printing out count is and the number for count. Now count is 2. Which is why beneath count is 3 on the upper right-hand corner of my screen, we see count is 2. After we print that out, we do it one more time. We say, let's take away 1 from count. And then we go back to line 3 and we check our conditional one more time. Count is now equal to 1. So when we check our conditional on line 3, we're basically asking, is 1 greater than or equal to 1? And the answer is yes. It is greater than or equal to, because it is equal to 1. And so because of that, we go into our while loop one more time and we say, let's console log out count is, and then the number. So that's why we see count is 1 printed on the upper right-hand corner of your screen. And then we decrease count one more time. We subtract 1 by 1, so count is now 0. At this point, to a human, we might say, great, we're done with our loop. And you can kind of think of it that way, but to a computer, what the computer's gonna do is the computer's gonna say, well, the last time I went through this while loop, I succeeded, right? So therefore, I'm going to keep going. And so what does this keeping going mean in this case? It means we'll go back to line 3 and we'll do one more check and say, is count greater than or equal to 1? And the answer is, well, because count is now 0, 0 is not greater than or equal to 1. And so therefore, the conditional for the while loop is going to return false. And once it returns false, then the computer says, great, I'm now done with the while loop between lines 3 through 6. I can now move on to line 7 in my code. Okay, so just be aware that the computer does do one extra check to make sure that it's false. And in fact, the by far the most common way for us to end a while loop is for the conditional to return false. And so just know that the computer is actually checking it, and at some point and at some point it only knows to return false, or rather it only knows to stop the while loop once the conditional expression there on line 3 returns false. Any questions at all? Yeah, question? Sorry, who is that? Yep. Oh, shoot. Sorry, I just saw you.
There like always be like a statement that changes the variable, so like the count minus that sort of adjusts the variable.
Yep.
Because otherwise, I guess it would just keep running forever and never stop.
Yep, exactly. So we'll talk about that right now, actually. So yeah, so this is a slide we were just on, and then obviously the other side of so I'm gonna come back to your answer, Charlie, in 2 slides. Okay, so the one thing for us to keep in mind is that a while loop will always check at least once. Okay, every while loop will run at least once just to check. In this case, we have an conditional. We just had the statement called false, and false will always return false, as you can imagine. And so because of that, when we hit line 1, the while loop is going to say, let me run once, let me check to see if my conditional is true or false. Oh, it's false. Great, so I'm done. I never run my code block, so I never run the code basically in lines 2 and 3. And so because of that, when we run this particular snippet of code, nothing prints out. And for that very reason is because our while loop started, it got back false as the first time, so it says, great, I don't need to keep running anymore, I'm gonna move on to the next line of code, which in this case is line 4. Okay, so this is hopefully pretty clear. The other scenario there then would be to say, hey, what if we have a situation in which our conditional is true? And in this case, Charlie, this probably starts hitting at your point of, well, in case when we look at a code block on lines 2 and 3, we never change the conditional expression. True is always going to be true, just like false is always going to be false. And so when we run this code, what's going to happen is we're actually going to keep printing this line out forever. The computer is not going to know when to stop because, as far as the computer is concerned, you ask me to do a while loop, and every time I check the while loop, it always gives me true. So I'm going to keep running and running. In reality, the computer is going to run this until either the machine runs out of memory, or most computers now have a better safeguard for this kind of stuff. When it feels like you're running kind of things, infinitely, it will probably kill it for you and ask you, "Hey, this is probably not what you meant to do. Take a look at your code." So this, I think, to answer your question, Charlie, is what happens when you have a scenario in which you don't change your conditional expression within your code block, and so you have this, what we call it, an infinite loop. So then this ties into this idea that, as you mentioned on line 3 there, we basically, whenever you run a while loop, a conditional for a while loop never has to return true, but it should always return false eventually. And so in this case on line 4, when we look at, once again, this code that says while count is greater than or equal to 1, notice how in the code block, we print out what count is, but we never change count. So just like in the previous example where we have the conditional is equal to true perpetually, this will also always return true for the conditional, and so the while loop will just run nonstop. So in this case, we have count is 3 running over and over and over again. Okay. Sorry. So this, once again, just goes back to the point that when you have a while loop, you want to be sure that at some point your conditional expression eventually becomes false. There is an edge scenario in which this won't be the case, and I'll cover that probably 6 slides from now. But just as a general rule of thumb, wherever you're writing a loop, always be sure that you're clear on when the code is supposed to or when the code is going to stop, because it is a lot more dangerous for a code to keep running than for a code to stop too prematurely. For us, right now we're just printing out things on a screen, and it doesn't really matter. It's, if we have a loop that doesn't stop correctly, we might just say, well, it pollutes my screen, right? And it's kind of annoying, but there's no harm done. Imagine if if in the while loop you're doing a financial transaction or sending an email or doing other some kinds of actual process with a user. Now imagine how dangerous it would be if you have a process that does something kind of not infinitely, but at least several 100,000 times before a computer stops you and say, hey, did you really mean to do this to this person this many times, right? So in practice or conceptually, it may seem very kind of, oh, it's more annoying, but in the real world, having infinite loops is actually a very dangerous practical thing. Okay, any more questions on while loops before we move on to the for loop section? Yeah, feel free to just chat questions. More raise your hand or just yell at me. Cool. All right then. Actually, I'm just gonna minimize this really quick. Okay, great. Okay, so that covers it. Basically, that covers the basics of the while loop. The other kind of loop that you'll see quite often and probably significantly more commonly than you will see while loop is the for loop. Like the while loop, a for loop also requires three key elements. The first element is where we had a while reserved word for the while loop. We have a for keyword, which is also a reserved word in JavaScript. So this means you can't have a variable called for, right? For means something in JavaScript, and the for loop is built into every implementation of JavaScript out of box. Now, instead of having one conditional expression, you'll notice we have three optional expressions. I'll walk you through in more detail what those are. And then lastly is we have our same block of code. So basically, once we decide we are going to run a particular block of code or a particular loop, what code actually gets run. Okay, so on line 6 there, when I talk about the three optional expressions, it looks kind of similar to a while loop. We still have our open parentheses and closed parentheses, except now in the middle, you'll see that whereas before we had a single expression, now we have three expressions, and each expression is separated by a semicolon. So here we have something called initialization semicolon, we have a condition semicolon, and then the final expression. For loop requires all three, so make sure you have all three written whenever you try to use a for loop. And what a for loop does is a for loop operates very much like you would think a loop does, to say, hey, let me do this over and over again. Now, if I was to ask someone, to do something over and over again, what are the things that I would need to tell them, right? Because instinctively, the first thing we would ask them is, well, when do I start, right? Or where do I start? And so that's what the first third of this is, the initialization. That basically creates an initial variable that lets you keep track of where you want to start. The condition then becomes, in the middle section, the condition then becomes very similar to the conditional we saw in a while loop, which is, hey, should I do this again? Yes or no. And so once again, just like in the while loop, the condition, the middle term, will always evaluate into a Boolean, and it's our job to say, hey, this is going to return either true or a false. If it's true, we do the code block. If it's a false, we don't do the code block. For the third part, the final expression, when we were talking about the while loop, we kind of relied on the user to be smart and know, hey, you want to edit your conditional within the body of your while loop so that eventually it gradually becomes false. The for loop is just a little bit more explicit than that. It will say, hey, every time after this loop runs, how do you want me to change the tracker, or how do you want me to change the variable that we created in the initialization step? And the goal here is to say that every time we change that variable, eventually it will get closer and closer and end up in a stage in which it will make the condition return false. So that was a lot of words. Let's see how it works in practice. On lines 9 through 11, we have a typical for loop, right? And in this for loop, you'll notice in the initialization, which is basically everything before the first semicolon, we have a simple definition. We say let I equals 1. And in practice, what this means is I is a variable, and we're creating this new variable called I, and we're setting the initial value to 1. That's the initialization phase. And notice how in the first bullet on line 1 there we mentioned how the initialization is run first, and it's run only once, right? Because if we want to track how many times we want this function to run, we don't want to restart our counter every single time. If we do that, then there's no point, right? Like we're gonna probably run it like nonstop or infinitely. And so for a for loop, just know that when you see the initialization step, just know that that part of the loop is run only once. Okay. Then once that's done, then we move on to the middle section of our for loop, so the conditional. So in this case, this is everything in between the two semicolons, which is I is less than or equal to 3. Like the condition in the while loop, here's where we check. Is I less than or equal to 3, right? In this case, it's is 1 less than or equal to 3? And the answer is yes, it is less than 3. So here's where the for loop deviates a little bit. Rather than moving on to the third part of our conditional, what we then do is we actually move into our code block directly. Between lines 9 through 11, we actually execute that code block, that block of code in between the open and closed curly braces. And in this case, what that block of code says is, hey, print out I is, and then the value for I. And so the first time this code runs, you'll notice what we're doing is we're saying I is, and at that point, I is equal to 1. So that's why on the top right-hand corner of my screen, we print out I is 1. After we finish running this code block, only then do we go back and return to our third of the for loop, the I++. After we finish running our code block, only then do we do the expression there, which is I++, which just means let's add 1 to I. Okay, and that completes an iteration of our for loop. Now, for a for loop, much like a while loop, a for loop will keep running basically nonstop until the conditional returns false, right? So in our first instance, 1 was less than or equal to 3. So as far as a for loop is concerned, is let's keep running, right? So after it runs I++, the next step it does is it actually goes back to the middle section and checks to see if I is less than or equal to 3 still. We don't go back to let I equals 1 because once again, that's the initialization. That's our tracker. That only gets created once. After it's created, all we're doing is modifying that number in that I++ and then checking it in the conditional to see if we want to keep going with our loop or if we want to stop. So on the second iteration, I++ makes I equal to 2, and then we say is 2 less than or equal to 3 in the conditional. The answer is yes, 2 is less than 3. So then we go into our code block and we run that block of code which says console log out I is, and now I is 2. After we run I is 2, we then go back to the I++, and now we're adding 1 more to I, and now I is 3. So then we go back to our conditional and we say, is 3 less than or equal to 3? The answer is yes, it is equal to 3. So then we go into our code block one more time and we say I is, and now we say I is 3. After we're done with all of that, we then go back to our I++, because remember, we're not done yet, right? As far as JavaScript is concerned, we haven't really gotten a stop order from this for loop just yet. So then we go back to I++, which is 3, 3 plus 1 is 4, and now I is 4. We go back to our conditional and we say, great, is 4 less than or equal to 3? The answer is no, because 4 is greater than 3. And because that conditional expression, that middle expression returns false, only then does the for loop end, and we go back and then we move on with our code. We're done with lines 9 through 11, and we move on to line 12. So that's, I guess, if you will, the life cycle of a for loop. Any questions there? Yeah. Go ahead, Katie.
I was just wondering how many conditions can we use in a for loop? Is there like a limit of how many of them can we use at a time?
Technically speaking, there's not any. But the way that we'll talk more about this when we talk about the and or keywords. But for now, just think of it as a single expression. Usually you use a single expression. It's just kind of more clean and more logical that way. The vast majority of examples you'll only be using a single condition, although it is theoretically possible to check for multiple conditions.
Okay.
Yeah.
Thank you.
Yeah, no problem. Any other questions? Okay, so we have a few more things to talk about. Oh, sorry, I clicked too fast there. Okay, so realize that when I described a for loop to you just now, the idea was we initialize a counter variable, we check that counter, we do our code block if that check returns true, and then we change the counter. There's nothing in there that says we always have to add 1 or subtract 1, or we're checking to see if something is greater than or less than. In fact, a for loop is actually incredibly flexible in that way. So rather than having us start at 1 and going up to 3, in this case, we can easily start at 5 and go back down to 1, right? So just like before, when we run this for loop, the first step is our initialization variable, so let I equals 5. Once we have that, then the first thing we do is we go to our conditional in the middle there, and we check is I greater than or equal to 1. It is, it's 5. So then we print out, console log out, I is 5. After we print out I is 5, we then go to the third part of our for loop, which is the final expression, and we say I minus minus, or let's subtract 1 from I, so now I is 4. We then go back to our conditional and check, is 4 greater than or equal to 1? Yes, it is. We then print out I is 4. And so we do that for I is 3, I is 2, I is 1 as well, right? After I is 1 is printed out, it means at that point I is 1. When we do our final expression for that iteration, we subtract 1 from I, so now I is 0. And then we go to our condition, we say, is 0 greater than or equal to 1? And the answer is no, it's not. So that condition is going to return false at that point, and that's when JavaScript also knows to end this for loop, is because we've reached a false condition. Right, so this is just to show you that it doesn't mean that we always have to start at a low number and increment by 1 all the way up top. We can actually start anywhere we want, and as long as we're basically changing it so that the conditional eventually becomes false, we're in a good state. It could be adding 1, it could be subtracting 1. In this case, same exact idea, except now we're adding by 100 instead of adding by 1. And this is totally valid, right? Because we start with a counter, we check it, we run it if it's true, and then we change it, right? So there's nothing in here that says it has to be going from smaller to larger or larger to smaller, or it has to be checked by this way. It just means as long as we're checking it in the right process, in the right order, everything else should flow through smoothly as well. Okay. This is one of the last examples we'll go through together as a class of a for loop. In this case, we can actually use a for loop to also go through a string, right? So if we look at the for loop there on line 4, the first thing we do is we create a variable called I, and we set it equal to 0. That's our initial counter, and then we say, hey, for our check, let's make sure I is less than letters.length. Well, letters is that string variable that we defined there on line 2, and so letters.length basically tells us how many letters are in the string. And so if we think conceptually about what this code is trying to do, is the first thing is we want to create a variable and say we start at 0, which is I, and then we're saying while this variable is less than however long strings is, let's do our code block, and then when we get to line 4, when we get to the third part of our after expression, after we run our code block, we're actually adding 1 to I. So I goes from 0 to 1. And then we check, is 1 less than however many letters there are in the string? If there is, then looking at line 5, we set the letter at that index to this variable called current letter. Notice how on the right hand side of the equal sign on line 5, current letter is equal to letters index I. The index I basically says what letter is in that position, is in the ith position. The first time we run this, I is 0, so we'll say whichever letter is in the 0th position, which in this case is A, is the first letter, because remember how indexes start at 0 and go all the way up to the length minus 1. And after we get that letter, we then print out current letter. So when we run through this code, I is 0, 0 is less than letters.length. So then we go to line 5, current letter is equal to the letter at letters index 0, which is the first letter in letters, which is A, and we print out A on line 6. After we print out, we're done with our code block. We then go back to our third final expression in the for loop, which is I++, and that basically increments 0 by 1. So now I is 1. Is 1 less than letters.length? Yes, it is. Great. So now on line 5, we're creating a new variable called current letter, and it's equal to whatever is in the 1th position of the letter string. The 1th position is actually the second letter, because remember how we start index at 0. So therefore, current letter becomes the second letter in the letter string. And so when we console.log out current letter, we're actually printing out the second letter, which is B. And so we do this over and over and over again, all the way until we get to G, right? So A, B, C, D, E, F, G. So G is the 7th letter in the string, which means it's at position 6, right? So we start I at 0, we keep adding 1 to I. Eventually, I is going to equal to 6. And then we go to line 5, we say, great, what's the 6th letter? Or sorry, what's the letter at the 6th position of letters? We'll say it's G, we'll print it out. And then when we do our final expression, we'll say, let's add 1 to 6. So now I is 7. And then when we go to our conditional, we'll say, is 7 less than letters dot length? Well, letters has a length of 7, right? There are 7 letters in there. So then that expression boils down to, is 7 less than 7? And the answer is no, 7 is not less than 7. So therefore, at that point, our for loop says, I've reached a scenario in which my conditional is false. So therefore, I can stop my for loop and I'm done. And so that's how this for loop is going to play out in terms of kind of running through and knowing when to start and knowing where to start and when to stop. Any questions on that?
Why can't you just console log out letters bracket I? Why do you have to assign it to a variable?
Oh, that's just in this case we want to just make it more of a shorthand. It's just a practice because one thing. So to answer your question, we could absolutely do what you're saying and just console log out letters.i. Generally speaking, when you're using whatever element is in an array, you want to store it in a new variable just so you don't have too many brackets floating around. So it's more of a visual thing and probably more of a best practice habit than a technical reason. Yeah. Any other questions on kind of how this for loop works? Yeah. Yeah. Sure.
Are there instances in a for loop when you would need to define the variables before the for expression or the for function?
What do you mean? Like, what would be an example of that in this case?
I think one of the while examples, or maybe this was in some of the rework reading, had like defined, I don't know, would you ever need to define I or current letter before you're actually inside of the loop?
Yeah. Okay. So realize we can't define I before we get into the loop because I is kind of what we're changing. Actually, sorry, let me take it back. We are able to define I if we want to, but in this case, just if you think about like a for loop, the idea is we want to determine where we start, right, and where we stop. And so generally speaking, whatever your variable you're using for your tracker, you always want to start defining it within the body, within your for loop definition. So when someone reads your code, they know, oh, great, Charlie's trying to start at I equals 0, right? You could say, I equals 0 on line 3 and use it throughout the rest of your code, but it's just not very clean, right? In that case, then the for loop is not self-contained. It's relying on something somewhere else on the page. Letters, on the other hand, is the variable that we do define outside of the for loop and we do use within the body of the for loop, so it's definitely doable. And in this case, we cannot define current letter until we're in the for loop because current letter requires the variable I to know what letter is currently on. And so maybe it's a bit of a chicken or the egg problem, but because we're working on the assumption that we should define I within the for loop, it means we have to define current letter within the for loop as well because it's dependent on the variable I.
And would there be any case in which somebody would define, say, letters inside of the loop, or do you want to do that first because you have to know whether I is less than letters or something?
Yeah, so in this case, we need to define letters outside of the for loop, and it's because realizing the conditional expression, we're checking letters.length. So if we define it in the for loop, then this code would error out because when the for loop tries to look for letters, it wouldn't find it. It would say this variable doesn't exist. So in this particular instance, we would need to define letters outside and before the for loop starts. Cool. Yeah, great questions. All right. Any other questions on for loops? Okay then. All right. So two more things I'll talk about that are pretty quick. I won't spend too much time on them because I hopefully once if you understand while loops and for loops, these two should be pretty clear. They could be confusing relative to each other, but conceptually they should be kind of pretty straightforward. Notice how one of the things I'm talking about when I've talked about loops is like we do this thing, then we check, then we do the next thing, then we check, then we do the next thing until at some point we reach an end state, right, where our conditional is false. One of the things that JavaScript also has for us that gives us a little bit more control over the loop is it actually gives something called the continue keyword, and the continue keyword basically says, hey, whenever I hit the continue keyword, let's stop this particular iteration or this iteration of the loop, but let's keep going with future iterations. So what does that mean? In the code example here we have let I equals 1, so we start at I equals 1. Our check is to make sure I is less than 5, and after every code block run, we increment I by 1. If we didn't have lines 3 through 5, then all we're going to do is we're going to print out I is 1, I is 2, I is 3, I is 4, and I is 5, right? Now, with this continue keyword, when I is 1, it will still print out I is 1. When I is 2, it will still print out I is 2. But when I is 3, what that's going to say is we're going to hit line 3, we'll say, is I equal to 3? And the answer is going to be yes, it is. So then we go into line 4, and line 4 says continue. What continue then does is it says, great, skip the rest of the iteration where I is equal to 3, and let's just move on to the next run or the next step. And the next step is I++, which is saying, hey, let's add 1 to 3. So now I is 4, and we go through our loop. So then we check to see is 4 is less than 5. The answer is yes, 4 is less than 5. And then we go through line 3 through 5. 3 through 5 doesn't matter because I is not equal to 3. And we go to line 7 and we print out I is 4 again. So when we run this function, what happens is basically the continue keyword allows us to skip the console log for I is 3. Put another way, the continue keyword allowed us to skip a particular iteration of this loop, but not have it impact future loops or future iterations. It's like me, taking attendance, right? Like me taking attendance for, let's say, 10 students. The first question I'll ask is, are you here? If the answer is yes, then I say, great, tell me your shirt size, right? Continue is basically saying, are you here? If the answer is no, I'll be like, great, I don't need to ask you what your shirt size is. Let's move on to the next student, or let's go to the next step, right? So continue basically allows you to skip the rest of this step, if you will, and move on to the next step without impacting any future steps. In the context of a for loop, how would it work? Very, very similar. Sorry. In the context of a while loop, how would it work? In this case, very, very similar. We still have our while loop where we're checking to see if the count is greater than or equal to 1. Except now what we're saying is, hey, lines 5 through 8, it might be a bit challenging to read, so I'll just kind of walk through it for us. On line 5 there, it's saying if count, when we divide it by 2, if the remainder of that number is equal to 0, then let's decrease count by 1, and let's move on to the next iteration of this. So what does it mean when I say the remainder of a number divided by 2 is 0? Well, if I divide a number by 2 and I have no remainder, then it means the number is even, right? So line 5 basically says, if the number is even, do lines 6 through 7. If it's not, then move on to line 9. If I do hit line 9 and line 10 just prints out the number, which is count is, and then the actual number itself. And then it also decreases count by 1. So when I print this out, what it does is, on the very first step, it'll say count is equal to 5, while count is greater than or equal to 1, which it is because count is equal to 5. So that'll be line 4. We'll go to line 5 then and say, if 5 divided by 2, the remainder is equal to 0, well, 5 divided by 2, the remainder of that is going to be 1, right? Because 5 is an odd number. And so 1 does not equal 0. So then I skip the rest of that if statement. I skip lines 5 through 8. I move on to line 10. I just say print out count is 5. And I decrease count by 1. So now count is 4. The next step is I go back to my line 4 and I check my conditional in my while loop again. I'll say, great, is 4 greater than or equal to 1? And the answer is yes, it's greater than 1. So now I go into line 5. I'll say if 4 divided by 2, what's the remainder? Well, 4 is even, so when you divide by 2, the remainder is 0. And 0 is equal to 0. So now I move on to line 6, where I decrease 4 by 1, and then I continue, which means I don't run lines 8, 9, 10, or 11. But I do go to the next step, which is checking my conditional once again in my while loop. So basically, by doing this, I basically am able to bypass line 10, the step where it makes me print out what count is. And so that's why when I print out everything from 5 all the way down to 1, you'll notice how I only print out the odd number once. I don't print out the even number once. And it's because whenever count is even, I hit my continue statement, and the continue statement lets me skip everything else in that iteration, including the console log statement. Does that make sense, everyone? Any questions? Okay, great. So if that's the case, then the cousin to that is the break keyword. And the break keyword basically is like the continue keyword, except it will stop this iteration, and it will actually stop all future iterations too. And so basically, whenever you hit the break keyword, it just means get me out of this loop, stop the rest of this loop at this point in time. And so in this case, if I have an initial variable called migrate and set equal to a, notice how on line 4 there, right? My conditional is true, and I never change it. So true will always be true. And so, and on the surface, it may look like I'm setting myself up to have an infinite loop. On line 5, what I do is I add a plus sign to my letter grade. But notice how on line 7, I check to see how many characters are in the migrate variable. If I have 3 characters there, then I hit my break keyword, which is say, hey, stop this loop. Like, don't just stop this iteration of it, stop this iteration and also all future iterations of it too. And so when I run this code through, the first time I run it, my conditional is true because it is true. I will add plus to my grade, and now my grade is going to be a plus. And on line 7, I'll check if my grade, so if a plus dot length is equal to 3, break it. However, a plus only has 2 characters, so I don't trigger the if statement on line 7, and I move on to the next iteration of my while loop. Well, my conditional is still true, so I go into line 5. My grade was a plus. Now I'm adding another plus to it, so now my grade is a plus plus. I go to line 7. I check to see if a plus plus dot length is equal to 3, which it is. In which case I hit my break on line 8, and once I break, that basically means I'm done with this while loop. I'm done with this iteration of it, and I'm also done with all future iterations of the while loop. So the break allows me to get out of the while loop, even though my conditional is permanently true. And when I console log out my grade there on line 12, I see the A++. Right, so break works almost identically to continue, except whereas continue skips the rest of this run, but moves on to the next run. Break skips this run and does not move on to any future runs. It just ends the loop. So same exact idea for break in a for loop as well. In this case, all we're saying is once I is equal to 7, let's break, let's end the loop permanently. And so that's why when I print it out, if I'm starting I equals 10 and I decrease I by 1 every single iteration, I'll print out I is 10, I is 9, I is 8. If I is equal to 7, then I'll break. Basically, it means I'm going to end this loop. And so that's why I is 6 and I is 5 do not get printed out. Any questions about break or continue? Cool. Yeah, that's pretty much it for today in terms of kind of lessons talking about loops, while loops, for loops, continue, and returns. I'll spend a quick 5 minutes on the debugging section. This part I'm not going to talk as much about. You'll have access to these slides, so feel free to look over them yourself. And the reason why is debugging is more of a holistic skill set and not any one particular thing that you need to be doing or learning. It's just something that comes with practice as you debug more and more code. So the good rule of thumb to keep in mind is, remember what I said yesterday, a developer probably spends more time testing and fixing code than they do writing it or even thinking about it. And so just because of that, bugs are always going to happen. Bug basically just means something is wrong with your code, and it makes it perform in a way that you do not want it to, or you did not expect it to. So debugging basically means going through, finding those mistakes or finding those bugs and correcting them. So I covered this a little bit yesterday. When you run your tests on CodePen, when you hit the run button at the top, it will give you back a screen very much like the one at the bottom here. I'll tell you how many tests were run and how many tests failed. Notice the green circle and the red X's there in that photo. The green circles correspond to the order of the test. So in this case, because the first test was a green circle and the next 3 are failures, that means when I look on my test, it means I passed the first test, but I failed the next 3 tests. Okay. When you look on the body of the CodePen, you also notice that you'll also notice how halfway down the page you'll see something called only odds returns a number, which is the name of the test. And beneath that, we actually get the actual error that we encounter when we try running it. Reference error is a very common error that you see, especially when you're first starting off. Reference error basically means you're trying to use or refer a variable that was not created. And this could be because of one of 2 reasons. Either you never created a variable called, in this case, sum to start with, or you create it somewhere else and you're trying to use it in a place where you don't have access to it. We'll talk more about what that means when we talk about scope, but just typically for now, whenever you see a reference error, it means you're trying to use a variable that you never created. When you're first starting off, this could very well be a typo, right? You could have, defined a variable, called it David, and then when you try using it, you might have called it something else, like David with an E instead of an I, right? So a lot of times this is just a very simple like typo or like a spelling error, but fundamentally it just means you're trying to use a variable that JavaScript cannot find, or as far as JavaScript is concerned, does not exist on your page. Also, beneath that sum is not defined, you'll notice how there's a few lines of code running. That's what we call the stack trace, and it basically is a way for you to understand how the computer got to your error. So not just the computer says, oh, hey, it's broken. The computer is actually going to say, hey, I tried doing this, which led me to doing this, which led me to do this, which led me to do this, and then I encountered your failure. So it's also a good way to gradually understand exactly which, or how to understand how the computer got to your error. The most important thing I'll mention here is at the very end there. So let's say take the first line under reference error, at only odds, which I guess corresponds loosely to line 12 if we're doing an alignment. You'll notice how it's at only odds. We have an open parentheses, we have HTTP, But if you look at the very end, you'll see it's only -odds.js, :11, :7. You'll usually see those 2 numbers at the very end, separated by a colon. The first number is a row number, and the second number is a character number. So that basically means it was trying to do something at row 11 at character 7. Usually the character number doesn't matter nearly as much as the row number, but the row number is really good because it gives you kind of a heads up as to, hey, the computer hit an error trying to do something on this line. So when you look through your code, rather than reading through it from top to bottom, you at least know kind of where to start looking or where to start kind of understanding where the error came from. Now, the row number is not perfect. Sometimes you make a mistake in line 1 that doesn't manifest or doesn't show up until line 10. Right? So in that case, if the error happens on line 10, you actually need to look at line 1. But directionally, the row numbers generally speaking, it does give you a good idea of where to start in at least investigating the error. And then failing tests. There are 2 reasons why tests fail. The first one is because you're trying to use code that JavaScript couldn't run, right? So you have a typo somewhere, you misspelled a function, you're trying to use a variable that doesn't exist, which causes a reference error. So that's like the first class of errors, it's like basic JavaScript errors. The second type of error is kind of more human related. It's just like, hey, your function, it runs, it just doesn't do what I want it to do, right? And so in this case, if you look at the error there, the expected 25 to equal, expected 55 to equal 25, that just means, hey, your function operated correctly. There was no errors in terms of it working or operating. It's just that we expected to get back 25 as the answer, and we got back 55. So maybe there's something computationally wrong with your code, right? So it's not a syntax error. It's just more like a logic failure or a logic error. Yep. And that's pretty much it for failing. One other thing to keep in mind for tests is that in JavaScript, usually what we will do is we'll ask you, whenever a function asks you to return something, please use the return keyword. We'll talk a little bit more about this in later sections, but just know that console logging something is not the same as returning it. Console log just means print it out to the screen so the human can see it. Returning means actually giving a value back to say, hey, this is what I'm going to give back to you, right? The analogy I always give is if my teacher or my professor asks me to do a paper, what I actually hand back to them, the final or the paper, like that's what return is. Console log is just more like a status update, like look how hard I'm working, or here's where I am. In this case, whenever you use a console log and the test is asking you to return something, that's like saying your boss asking you, hey, can you turn this report? And come day of, you don't hand them a report. You just kind of say, hey, I worked really hard on this, right? Like when the function asks you to return something, it needs you to actually return it, which means using the return keyword. The reason why I bring it up here is because by default, everything in JavaScript, all functions in JavaScript return something. And if you don't explicitly tell it what to return, it will return back undefined. And so whenever you have a function that's returning back undefined, or you get back undefined as your answer, it most likely means that in your function, you didn't put a return statement, or at least you're not returning the right thing. And then lastly is, as you get more comfortable with the test, like I said yesterday, never change anything in the test. The tests are meant to be fixed, right? You don't want to change the test, you want to change your answers. But feel free to read through the test. And I think most of it is pretty human readable. You might not understand exactly what every line is doing, but it is written in enough of like a plain English intent that you should be able to kind of get a good summary, good, I guess, best educated guess as to what the test is trying to test for. So at least look through it if you're having trouble, to at least try to figure out what the test is trying to look for. The last few slides I'm not going to go through. It's something called the debugger, Chrome DevTools, and VS Code. And this is very dependent on which tool you use to test. But basically, these are just kind of more advanced tools that you use to pause your code at a certain point or go through and go through a code line by line. You won't need any of this for bootcamp prep, and you probably won't even need it for the full-time curriculum, depending on kind of how you debug. But I'll leave the slides in here so as a reference. So if you are interested, or if you use VS Code or Chrome, feel free to take a look at it. But once again, these are kind of more optional, more advanced debugging tools, and you don't have to use them for this class or for the full-time curriculum. So that's pretty much it. We covered a lot on loops, especially the while loop, the for loop, the break, and the continue keywords, and then we went through a really quick recap of debugging. Are there any questions before I let you work on the first workshop? All right, cool. If not, then I am gonna stop this video and I will get you broken out into your rooms and you will start the workshop.